Hey everyone, how are you today? I'm Eyal from Modalics, also known for my various music projects, coding projects, software for people, etc. So I'm here today. I'm going to be continuing working, generally speaking, on this thing that's kind of like this, algorithmic music language, but more specifically I'll be working on what I started to work on the previous stream, which is learning to wrap this C library called libuv in hopes that I can use it to write a language server based on this. And this was a fun project that I started yesterday because it means that I have to learn the C library called libuv that I've never used before, and then find like a normal interface around this in C++. Yeah, so let's get going. Let's see where we were last time. So this is where I am. So what I started to do, this started out as the an example by the the echo TCP server example by that library libuv. And what I started to add objects. So the first thing I was just about to do is that I created this server class, and this is meant to start encapsulating patterns that they've used, but they've used a lot of like raw memory allocation, like malloc, and then like free the stuff later. I didn't like it. I wanted to have some normal RAI approach to this. And what I learned just before we ended the stream last time is that I've learned that they did these things. Let's see if I still have the original functions there. Let's go and read their original example for a second. Hello. So yeah, so in their original code, they did what is it called, TCP echo server, right? This was their example, and I didn't like this pattern at all because I felt like there was a lot of weird loose things here. Like for example, you see that there's this callback that they set called on new connection. Can I zoom? Yeah, I can zoom. So on new connection, the idea is that on new connection would do restart and pass it like you see, this allocates a new client. Here's what happens: allocates a new client, and then later when you actually read the thing, I think you pass in this echo read, and this passes in what is it called, echo write, right? This passes an echo write function, and echo write function will free it. So there's all this like hoops that the memory would go until it gets allocated and freed. I did not like this idea. I wanted to see if I can somehow wrap this in a more streamlined RAI style thing that would be more suitable for C++. So I started by slowly but surely creating all these objects. It's not good yet, but there's still most of the C stuff is still in there. So yeah, I need to. So the one thing I did learn when I saw this is in my server class that I just started to make. There it is, server struct. What I did was that when I had this create client call that keeps like a more of like a vector of client. Client is more like a unique pointer around the actual thing. Yeah, so I need to kind of streamline this flow so that it has some sort of, it kind of so that it doesn't expose to the user this whole raw memory allocation thing. Yeah, so I still had to create a free function here because unlike in C++, free function function pointers in C don't allow you to capture state, so I couldn't just pass a lambda. That would have made my life so much easier. So what I'm going to do is I'm going to basically wrap these callbacks in these let's call them private free functions, so that the user will not know about these free functions, but they eventually will call lambdas for the user. That's how I will hide this level of annoying detail from my user, and I can have like some normal interface that will be more usable, I think. So okay, so right now you see this on new connection thing. All of this stuff is probably, maybe I can start with that now. All that stuff can hopefully be moved. Because eventually I would want just the user to just have like a main function, spawn a server object, and then maybe pass a lambda for what happens on connection or on new message. Something like that. That's really the interface I would want. I don't want the user to do all this stuff. I want to hide that from them in some way. So, okay. So what I did find when I did this on new connection thing, I've managed to grab the void pointer from this object, from the stream T. And that's where I did a cast to my own object. Then I could create the client here. But what's still missing, I guess. So let's follow the exact flow that I've done. So the user calls listen, and then I initialize the this UV listen thing and pass it the connection free function. Then I grab the server from it and call create client on it. The part I need to do is that I think I'm going to need to somehow communicate the specific client that was created to the user, right? Because yeah, so the server, when a new client is created, basically the user needs to know about this client, because the user would need to the user would need to know that a new connection started, and later it would need to know when a new it would need to do this vibe, right? If this echo read is actually should be a user function. That's will eventually be whatever the user does when a message came in. I'm going to need to refactor this as well. Eventually my user just wants to say, hey, tell me when a connection started, tell me when a message came in, or something like that. Okay, so let's see what we can do with this. So let's see what we can do with this. I just want to say, as usual, I'm streaming this on multiple platforms. Some of you are watching this on Twitch, some of you are watching this on YouTube, Facebook, Twitter, LinkedIn. Send me a comment, and I would try to put, if you have a question or something, I'm going to try to put your comments on screen, so that everybody can kind of tune in and chat, even if somebody else is on a different platform. Okay, what else? Let's see, how am I going to slowly simplify this into what I would consider normal. Create client. Yeah, I need a way for the client itself, because at this point I do know what the client is. I could move all those functions into the client, and I'm going to use this interface to somehow tell the user stuff, the user of this class. But let's start by first of all, I'm going to move all of this into the actual client class. So the client is basically a vector of client. Let's call it something like and this actually happens here, right when I started to read. So I'm going to need new client is actually me, so that's fine. Like I can just give it this, right? This is basically, I think, what it wants, right? Oh, it wants the cast. So let's have a function for the cast, something like does it want the handle or the stream? These are all these like fake base classes that they try to do in C. So get stream. So this would be UV stream P, get stream. Can I make this const? Okay. It's so weird that I could use static cast here. I thought I should be able to. I don't know why I can't use static cast here. This is a really weird way in how they've done it. They've implemented this so that they have these objects stacking the different base classes on top of each other, like just as plain members in a struct, and they've used casting to grab the part of the interface they care about, which is a very much it's very weird way to imitate object oriented, but I guess that was the way to do it in C. So this is get stream. Okay, and then oh, they want the server as well. Okay, that makes sense. So I can actually probably just pass this the constructor, because the server creates the client now. So we want first the server, then the client. So this is going to be the client. This is going to be the server. So in this, if it's accepted, oh, but you know what? If it's not accepted, I need to destroy this client. That's interesting. Right? Like I need to see if the server accepts this new connection. So maybe I need to do this thing externally. I need to do like have something that like a function that creates the client. Interesting. Okay, so that means I will not do this. I will not have a unique pointer here on this level. I will have a regular UV TCPT as just a member. And this thing, I'm going to have some function that will do all this creation so that I can also optionally create it. So I will do something like a stud unique PTR of client, create client, create client. And this should also take this server. And then I probably can pass this by reference, by the way. I'm not sure why. I don't think I need all this pointer bit for the interface. Well, let's start with the pointer just to be compatible with whatever they did. So, so I need to now TCP init. So this is yeah. So, and then that means the client itself should be initialized with right, and I think it's just a struct. I should be able to just copy it, right? It should be, I think so. I think I should be able to do some to actually initialize with something like a const. It's be reference. This is gonna be client to use. Client to use. Okay. This is going to be stream from the no. Can I just initialize? I can just make this a pointer from a pointer to this. Oh, because it's const. Yes. Okay. Let's go with static cast now. This was so weird before. I don't know. Okay. So I have a create client. I need to UV TCPT. This is like the actual raw client or something. Then I'm gonna basically do this thing. This is basically like calling the constructor, right? Which is unfortunately needed. And then when I'm finished with this, so I need to see if this is accepted. So now, oh, I still need the stream thing. No, so no. Let me do something else. I'm just going to. I think what I'll do is I'll create the client. So I will still create the client like this, have it own this thing. But then I will probably optionally not return it if this fails. This is what I do. So I'll do something like auto client equals stood make unique of client. And you know what? Then I can still, yeah, because you know what I can do is, yeah, I can still wrap this in the client class. You know what? I can go back to what I did before. Maybe this would make sense. So I will initialize with the server, but then, oh, actually, I don't even need this. I can just initialize it. Then I will have like a Boolean function that says bool. I don't know. Let's look. I think it's like register or something. Register client. Or yeah, register two, and this would take the server. And I'm gonna wrap this in. Oh, I still need this TCP init thing. This is still needed here, right? So this is needed here. Then when I'm registering this, I would try to register with this. I don't need this raw client thing. I don't need this. And this would be a part of this register to function. So accept is server and the stream. Okay, so if it's accepted, then start the read, and this would take the stream. So it's here. We can also start with the stream equals get stream. Just go through the casting. Here it is. It's casted once, casted twice. This allocator thing is something pretty horrible that I've not found a solution for just yet. And if not, just close it. And if it's no problem, just return true. And on close takes the handle. So I should also do the same thing with the handle. Get handle. The good thing now that all these can be just private. These are all just things that this register to function would use. UV handle T. Okay. So close it and then return false. And I don't need even this else because this will just be returned. So this is my register to function, and that means that basically the interface I can use. And this is not perfect now, but this would be a start because I'm still not passing a lambda from the user. But now I'm creating a new client, and then I do client register to if client register to server return client or return null PTR. So, and I've done it like this because now I will have some memory safety on this, because that means this will be created locally in this scope. And if only if the registration succeeded, I'm going to get a valid pointer back. If not, I'm just not going to get it. And that's why now when I create this right here, this would be a vector of a unique pointer of client, right? And then when I create this, I would do something like, if auto client equals create client. This is to have the server again. Then in place back, this dude move of client. Just move it inside and just and then I probably will also make this so that this will kind of return clients back get, otherwise return null PTR, right? So that's how I will communicate to my users if this has failed for whatever reason. Notice here I'm passing a raw pointer back because a unique pointer does not help the user in this. The user does not need to do ownership storage about this. They just need to know if this creation operation succeeded or not. I could also pass like an optional client, but that has other issues, so I will not do that. Okay, and that means when I'm creating the client from the server, I will do something like this will pass the stream basically. So this would look something like if to client equals this, right? So if the client, right, do something like this. If the client worked, then I'm going to do something with the client, right? So it'll be something like, for now, client creation worked, and whatever else, I should do something else. Now, if that worked, I would have access to my client in this function. So hopefully this was a good flow to do this. Let's see if everything compiles. I'm still hard coding a couple of functions here. Allocate buffer, I might keep hard coded just because I don't really know if I want to, at least for now, want to expose the user with a memory allocator. I might still just keep this allocation function just so that the user will not have to do this. I'm still not 100% sure what's the best way to I might be able to grab like a memory buffer from the server. I don't know. I'll have to read more about how this function works. And I think there's a deallocator too, right? There's something. Yeah, but anyway, this echo read thing, this is going to be the function that's the user is going to write. That's the most important part about this, I think. So the user, so this is how this is like the work that I've done to kind of hide these memory details so that they're encapsulated in the client creation part, and then hopefully I can give the user a little bit more information about this, because the user would need to store some vector or something on of these objects. Okay, let's see if I'm still correct. I had this like tester project that I've done using Juice, where I will be sending. Something got stuck here. I will be sending some message. Okay, so client creation worked. I'm still not, but as you can see that this worked because on the client side, I can see send message hello, received hello. So we have Oriam here, says like your videos. Thank you so much. I'm so happy that people like my stuff. Yeah, I'm hoping, I know this is a bit technical for some people. I'm hoping it's not too wild. Yeah, thank you very much. I really appreciate it. Really appreciate it. By the way, hopefully the audio is okay. Hopefully the AI generated music that is the only thing I can play here is fun. I'm going to be, let's see, let's put some more coffee in the coffee machine. Give me a second. Might mute the microphone for a second when once this starts, because this coffee machine makes a lot of noise. No idea why. Maybe it's not so bad. Hopefully you're not suffering too much from the coffee machine noise. Okay, so I'm going to move basically everything that's out here, everything into its own file. So let's call this something like a server. Because I want to have a clear distinction on what is user space here and what's not. So all this would have to do is just include server. And then the server, first of all, I need to move everything that's out here into the namespace. And very soon what I'm going to do about this, I'm going to be putting all these like as private implementations, so the user will not even need to include UV directly. The user can just include the server and not be exposed to functions like this UV, blah, blah, blah. I don't want to make the user force them on the user namespace, basically, because there's might be name collisions and other really weird things that happen when you're just directly include C libraries. Okay, get more coffee. How's everyone doing? How's everyone doing today? What are you doing for the weekend other than watching dev streams, doing wrapping C libraries for musical applications? Commit and say move wrapped all server operations in an object. Okay. So let's start by cleaning the actual operation so I can move things to the user. So right now, I am on new connection. So first of all, I want to tell the user. Let's see how am I going to think about this. So I need the user. So there could be multiple connections here from like multiple clients into logging into the server, and I need some way to tell the user, hey, this thing gets created. You might want to store this in a vector somewhere so you can know which client it is you're talking to. I think that might be important. And also I need to tell the user, so I might need like a user object there that the user talks to. Think about this. Alternatively, I can kind of manage this list for the user. Like the part that's always confusing to me about this stuff is that like let's say you get a callback says a message came in from this client, right? There could be multiple clients. The user usually has some state that deals with that particular client. Like they know what are the previous messages that came from that client, etc. Like this, the user of this class usually has some stateful relationship, let's call it, with that particular client. So I think that what I would need to do alternatively, and then maybe I can test. Maybe usually the way this works is that the client gets disconnected after a call. I don't know, but I think this connection should be going on for a little while, and the user should know, hey, message came in, and be able to send messages back. So I think I should be able to let the user know. Like I somehow need this client class eventually to maybe broadcast, tell the user something like, hey, a message came in, and then let the user also write something back. Yeah, that could help. So let's have a look exactly at how it is. So first of all, let's look at this echo read function, because the echo read actually called also UV write. So UV write is actually something that writes back into the client. I should be able to wrap this whole thing, the buffer, UV buffer in it. Blah, blah. I probably don't need a lot of these C stuff here. Yeah, so there's a callback here that happens when a message is read. This is something I'm going to be getting from libuv, and then there's a write. Let's start with the write function. It might be easier than the wrapping the read function. Yeah, so first of all, let's initialize this. So it won't tell me that it's not initialized. And then let's have a function here called like, void send message, basically something like send constant string message. Something, I think that's pretty much what I need here. Good. So I need this thing. They have this type called write rex. This is write t. What's a write t? So why do I need to malloc this? That's interesting. Why can't I just make this thing on the stack? I mean, I think I would, right? Is there something here? This buffer must remain valid until callback is called. Oh, that's why. Okay, this is annoying. So the reason why this is because they probably do some async thing there. So I need this object to be alive until this thing, write callback, echo write. So only when I'm okay, and this is where I should be freeing this. This is pretty horrible, but let's see if I can. So I need to basically pass memory that I would later delete. Oh, this is bad. How am I going to do this? In a Lambda world, I could just pass like a shared pointer and this will take care of this. But here, there's not going to be any objects. Here, there's no captures that I can use. I need somewhere where this thing would kind of allocate an object. And then pass a pointer to this, like buffer, right? Giving a pointer to this buffer. Or an array or something. So let's think. I need to buffer init uv write. Yeah. So for now, I might just do. Yeah, so this one, so there's yeah, so I might have to do it their way for now. I'm not sure exactly what would be a better way to do this, because I can hold some shared pointer in there, but I don't know. I'm not sure how the lifetime of that object would remain alive in a way that I mean, if I knew that there could only be one write, maybe I would do this, but I don't know. So let's start by just wrapping this in functions that I will maybe pass to a CPP file or something. So maybe this will be something like echo read. So let's do something like right, because I can write this. So first of all, I need something like, let's call it like send message, right? Echo read and so weird the way they've done this. Char base, I just do length and then base. Yeah, basically it's an object that is like basically a void pointer in a size. That's really what this buff t is. Yeah, so first of all, you know what I can probably do? First of all, I can probably do a few help out with that. So first of all, I can do something like redirect t. Let's call it something like allocate buffer. Right, and this would just encapsulate this. This would need basically another buffer with the data, but I think I could probably just do something like, you know, void pointer data in size or something, or whatever, something like that. Or size t, whatever. Const void pointer or const char pointer. Okay, char pointer, that's fine. And then, first of all, this should just be, could be just O2 rec equals new right rec t. So I definitely don't need this thing. Oh, but the size, I think this should write into the size, right? Oh, okay. So this just, yeah. So I can probably just make an object, right? I can, because the problem is that the structure of this object is not going to get called. I'm going to manually write. So I'll just do with this allocate buffer, and then let's just do void deallocate buffer. Let's just do a free. Free write request, okay. Deallocate buffer, it will take, I guess it's fine, right? I can just use that data. It would just be delete, right? That's pretty much right. Or sorry, and this, let's just take this, not chart data, but this thing, and this would, oh, but this is like my object that has the request and the buffer. This is so confusing the way they try to connect these things. Like they wanted to, this was like a way for them to, I guess, to associate the specific buffer with a specific request, so that there's always going to be like a pointer knows which one it is, if I understand correctly, and which, I guess, request was associated with this thing. Let me think. Because the thing here, when I'm eventually writing this is just going to need a buffer, right? Right, just give me the just give me a buffer. And the buffer already knows its size. Oh, number of buffers. That's weird. Okay. Number of buffers. That's fine. Okay. Handle. Okay, request and handle. So what does it need? Remain valid. This is so weird that it does that. I keep thinking if I can just wrap this whole thing in one object that would keep the lifetime. can think if I can make this whole thing one function. I think if I can do, instead of this, if I can do something like, because I think it's more like, you know, send message, right? Like something that's, which takes, because what I probably want to do is something like create like a callback here that says there, what is this thing echo right? So yeah, this thing in status. Yeah, maybe I can just do whatever. Maybe I can just use whatever they did. So confusing. So confusing the way these C objects are connected. Why do I need to, why did it need to know this particular thing? Like why did I need to add this extra information to this? Because when I get an echo write, free write requests. Oh, okay, and you see why? Because because this is basically like a way to call the virtual destructor. Because then they wanted like, okay, this is your type. We're gonna know, like that it's your type. You can just erase that type. Which is fine. I can do that. And that also means that I can probably wrap this in a better object. You know what? I think I could. I think if I'll manually call new and delete, I can have at least one constructor and one destructor for my. So let's do something like that. Let's do something. If I write something like, let's keep their object there just for reference. So what I need is, let's call it a message object or something. And the message would take something like a std string for now. I'm just going to be based on strings, text. And then this would yeah, I might even be able to hold this as std string. Could also have this like a vector of char. I don't know, let's start with this std string. Text to use. Text to use. And then I should be able to on demand get a buffer from this. Basically, I need to whenever is needed, or maybe I can just hold the buffer. So and that's another way. So I can just hold the buffer here. This would have the buffer, but this would be a pointer to the buffer. And on demand, this would have something like what's this called? Initialize buffer, right? Init buffer or something here. Init UV buffer init, this whole thing. The data is, by the way, is this copying anything? No, this isn't copying anything. So I do need to store the text here. This needs to make sure this std string text. So yeah, I guess this is fine because that means I can, if this isn't a copy, I can just ask for this. I can do something like get buffer. I should store this on the constructor. And get buffer would just, give me a buffer. Sorry, buffer. Oh, but then I need like a pointer to this, right? It's so weird. Okay. So I do need this to be held here. I can just store this in the constructor. This is not going to change. Buffer dot. No. Cannot cast char to construct. Jesus. Why can't I do this? Isn't there a way to do this? Like make this a char? Can I just char? Sure. Yeah, and then I'm copying this. I'm holding this. So just return the address of the buffer. And when I'm going to, sorry, pointer, and not a const. And then when I think I'll need a destructor for this. Is that what I need? I mean, if that's the case, I don't even need a destructor. I just need to make sure I call this. I just make sure I call delete on this thing. Right? But then how do I pass this? If I get when I write this, I need to pass something that gets casted into this. Is that what I need? Yeah, so I think I should be able, if this would be the first element, this is almost like inheriting. This should be something like, right, or something. Then when I allocate this, I should just be able to do, first of all, auto message equals new message with so confusing to me. Right, I might need to close the stream. I'll be back in a couple of hours probably.